The electrophorus. The following items were used in the preparation of this educational resource: multi-purpose cleaning cloth, scissors, 3D printed handle, tape, copper disc 15 centimeters in diameter, super glue, small wooden dowel, long piece of wire for the ground connection, small metallic disc cut from the bottom of a coffee can, thread, magnet, small piece of aluminum foil, flexible cutting mat. What is an electrophorus? An electrophorus is a simple electrical device used to generate and transfer small amounts of electric charge. The first electrophorus was invented by the Swedish physicist Johann Carl Wilcke. According to Wikipedia, the device was later improved and popularized by the Italian scientist Alessandro Volta, a fact that explains why it is commonly known as Volta's electrophorus. What are the parts of an electrophorus? In general, a basic electrophorus contains the following parts: an insulating handle, usually made of plastic or rubber, a conducting plate, usually made of brass or copper, and an insulating base, usually made of plastic or glass. To charge the insulating base by friction, a small piece of fabric is also needed. Let's assemble a fancy electrophorus. How does the base of the electrophorus get charged? When the top surface of the insulating base is rubbed with a piece of fabric, electrons naturally move from the fabric to the base, leaving the bottom of the fabric positively charged and the top surface of the base negatively charged. The base can also become positively charged if a different material, like glass, is used, but we will be using plastic in this video. How does the plate of the electrophorus get charged? When the neutral conducting plate is placed on top of or very near to the charged surface of the base, a redistribution of charge occurs on the conducting plate. As an approximation, the charge distribution on the plate can be depicted as shown in the figure below. Electrons accumulate on the top surface of the plate because they are repelled by the excess negative charge on the base, which in turn leaves the bottom of the conducting plate positively charged. In this discussion, the effect of polarized molecules in the base, now shown on the conductor, will be assumed to be negligible. The electrons that gather at the top of the conducting plate can be easily removed by simply touching the top of the plate with the wire connected to ground. A long wire connected to a copper pipe under the sink is a good option. When the electrons leave the plate, it is left with an excess positive charge, and we can then say that the electrophorus is charged. The charged plate can then be used to attract a small piece of aluminum foil, for example. Let's see that in action. Observation. It is important to note that the excess electrons on the base do not simply jump to the positively charged bottom part of the plate because the base is an insulator and captured electrons cannot easily escape from the surface of this type of material. As far as I know, this is an experimental fact that cannot be fully explained within the framework of a simple theory, and I will take it as a given. How can we discharge the electrophorus? This can be done by simply touching the already charged conducting plate with a grounded wire. By doing this, the plate becomes neutralized by drawing electrons directly from the ground, as suggested by the black arrow in the figure to the right. Note, the plate should not be resting on the charged base during this process. Remember, electrons were repelled by the negatively charged base. Once the conducting plate is discharged, we can recharge it again as explained in the previous slides. Let's see that in action. Can the electrophorus be discharged by simply touching a small neutral conductor with the charged plate? If the conductor is very small relative to the size of the electrophorus, only a small fraction of the excess charge present on the conducting plate will be transferred to the conductor by stealing some of its electrons. After contact is made, the small conductor should be repelled by the plate because like charges repel each other and because the small conductor is expected to be very light. Let's see that in action. There is an interesting way to discharge the conducting plate using a small conductor hanging from a thread. The process works as follows. After the small conductor is charged by touching the charged plate, a grounded wire is placed to the right of the conductor. The conductor is then attracted to the wire and gives away all its charge upon contact. Once neutralized, the conductor is attracted back to the still charged plate and takes away some of its charge. Since like charges repel each other, the conductor then swings back toward the grounded wire and is discharged again. This back and forth motion continues and the hanging conductor oscillates until the plate is, to a good approximation, fully discharged. Note, if a grounded wire is not available, you can use your body, which is a relatively large conducting object, as the ground. Let's see that in action.